See, when we apply this formula for this diagram, we get this one. Okay, N1 by OB minus of minus will become plus minus OB. N2 by BI1 equal to N2 minus N by BC1. Next one is ADC. What is the formula? U is equal to DI1, and because this is the object distance and this is the image, DI is the image distance, R is equal to DC. Substitute in the formula, then we get the second one. So for the thin lenses, what will happen? Actually, this is very small value. This is very small value. So therefore, DI1 is DI1 and BI1 both are equal. Now add all LHS values, add all the RHS values separately. Now, when you add it, we get this answer, this value. Now we will simplify now, because we came to know that BI1 and DI1 they are same. So we just cut it. Okay, BI1, DI1 is same, so their value is same. N2 by DI1 and N1. N2 by DI1. That should become minus N2 by. Final image is I, right? So object distance is DI. Object distance is this is N2 by DI1. See once again, N1 by OB, BI1 and DI1 is same. So what is the object distance here? Object distance is this one is N2 and this one is N1. Okay, N2 by DI1 and N1 into N1 by DI. 1 second, give me 1 second. We are adding both the LHS and both the RHS on the both LHS together and both RHS together. So what happened is the first this equation is for this diagram. This equation is for this diagram, and add both the LHS and add both the RHS. Okay, so we'll get the answer now. So once you get it, we'll start simplifying now. Can I erase this part? This part. Yeah.
Yes, sir.
No. Now, when you erase this part, so what will happen? N1 by OB. What is remaining now? N1 by OB plus N1 by DI equal to N2 minus N1 we will take common. N2 minus N1 we will take common into 1 by BC1 plus 1 by DC2. 1 by BC1 plus 1 by DC2. Okay, 1 by DC2. Let it be equation number 3 now. Let it be equation number 3. So now, equation number 3. Now we will substitute the values now. What is BC1? BC1 equal to R1. BC1 equal to R1. DC2, let it be R2. OB, let it be, the value of OB is what? Infinity. If it is infinity. If it is approaching infinity, and DI1 will be, DI will be F. Means if the object is at infinity, image is formed at the focal point. That is the meaning of that. So when we substitute these values, N1 by infinity, 1 by infinity will become 0. Okay, I'm just writing the values. Plus N1 by DI1, that is DI is F, which is equal to N2 minus N1 into 1 by BC1, that is R1 plus 1 by R2. So this whole value will become 0. 1 by infinity value is 0. 1 by infinity is 0. So what will happen? N1 by F is equal to N2 minus N1 into 1 by R1 minus plus 1 by R2. 1 by R1 plus 1 by R2. Okay. 1 by R1. Sorry, this is minus R2, right? This is minus, sorry. This will become minus. This also will become minus. dct is minus 2. So we got n1 by f is equal to n2 minus n1 into 1 by r1 minus 1 by r1 minus 1 by r. Now what do we get? We'll cross multiply this one. We'll cross multiply n1. So what will happen now? 1 by f is equal to n2 minus n1 by n1 into 1 by r1 minus 1 by r2. Now, so it is equal to what? 1 by f is equal to n2 by n1 minus 1 into 1 by r1 minus 1 by r2. 1 by r1 minus 1 by r2. So n2 by n1 is equal to what? n2 by n1 is equal to n21. So 1 by f is equal to what? n21 minus 1 into 1 by r1 minus 1 by r2. Is that clear? So this is what called lens maker formula. 1 by f is equal to n21 minus 1 into 1 by r1 minus 1 by r2. Once again, see, we got this equation. Now we are going to substitute the values. BC1 value is R1 positive, whereas BC2 is against the direction of light. This is against the direction of light. This is in the direction of the light. So that is why we got plus R1 and minus R2. Suppose if the object is at infinity, image is found at focal point. So substitute all these values in the equation here. Then after that, we got this value. After that, what we are going to do? We are going to cross multiply this. N1 we are cross multiplying, and we get this equation. Later on, n2 by n1 is written as n21. Is that clear? Is that clear?
Yes, sir.
Yeah. Now,
Yes, sir.
yeah, we will go with the next formula. What is that? Equation 3 and 4. So, now I'm going to erase this. So once again, I'll go back to the previous equation. N1 by what I get here? N1 by OB plus N1 by DI equal to what? Equal to N1 by F. How did we get this one? How did we get this one? We'll just write again the equations, the previous equations. The previous equation, what is that? We have N1 by OB. The previous equation N1 by OB plus N1 by DI equal to what? N2 minus N1 into 1 by BC2, 1 by BC1 plus 1 by DC2. Next one, this is the first. Second equation, what is that? We got N1 by F equal to N2 minus N1 into 1 by BC1 plus 1 by DC2. Okay, this was the equation. We modified this. How? When we substituted the value, we got this one. Now what we are going to do, this is equation, let it be, these are the two. When we solve these two equations, what do we get now? See, this value is equal to this value, right? See, RHS is same, but LHS is different, is it not? So what we are going to do, we are equating this value to this value. Understood? We are going to equate. See, this was the equation which is given here. And the next, after substituting the values, we got this, right? This equation we got. We are writing here. So we are equating both the LHS values. When we equate both the LHS values, we get this one. Got it? Did you understand?
Yes, sir.
We are only taking the LHS values, not the RHS, because RHS are same. Both the RHS is same. LHS is different. So we are equating both of them. Now, later on, what we are going to substitute now? We got this one. So now in this one, OB value is how much? Minus U. And DI value is plus V. So we substitute that value now. When we substitute that value, what do we get now? That is N1 by minus U plus N1 by V is equal to N1 by F. So N1 will get cancelled. So 1 by F is equal to 1 by V minus 1 by V. This is also the lens formula. Okay, is that clear? This formula, what is this formula? This formula is said to be lens maker's formula. This formula is said to be lens maker's formula. Is that clear? Is it clear?
Yes, sir.
Okay, so copy this. Then we'll discuss about power of a lens. Then combination of lenses pending. We'll finish off this one. This is very important lesson. Okay, this lesson wave optics is very important. Carries 1 5 marker, 1 3 marker, 1 2 marker, and maybe two 1 markers also. These 2 lessons are very important. So please, and also there will be case study also. 1 5 marker, 1 case study, 4 marker, then 1 3 marker also, and 1 2 marker also, and then 1 2 mark, 2 1 markers also. So you can understand how important it is. These 2 lessons. Now, and also no one expected in the case study, everyone was expecting the case study would be from the total internal reflection. But when you see last year's paper, the case study was not from total TIR. It was from refraction through a spherical surface. This on this formula, refraction through a spherical surface. That based on that diagram, they asked the question. The case study. They made it complicated. So please keep it in the mind. He can make any case study. Got it?
Yes, sir.
Are you done with this, all of you? Are you done with this?
Done, sir. Yeah.
Okay. What about Shivakshi?
Yes, sir. Done.
Okay. Sure. So we'll go with the power of a lens now. So please do write and practice these derivations. Okay. At least once. At least write this without saying once. That will be a practice. Otherwise, we'll forget this derivation, and these derivations are very important. Now, power of a lens. Power of a lens. So power of a lens is what? Suppose this is the lens. So what happens? Bending. This is delta. Okay. So this is the height. H is the height and delta is the angle. And F is the focal length. F is the focal length. Capital is the focal point. So this is also delta. So how do you define this power of a lens? Reciprocal. There are 3 definitions. Reciprocal of focal length. Reciprocal of focal length is power of a lens. Now, after that, we can write P is equal to what? P is equal to 1 by F. And F should be in meters. This should be written, F should be in terms of meters. And we have one more definition. What is the second definition here? That is the ability of the lens, the ability of the lens to converge or diverge. To converge, it's not right. The ability of a lens to the ability of a lens to converge or diverge. To converge or diverge the rays. To converge or diverge the rays is known as focal power of a lens. One more is there, the tangent of the one second. So the tangent of the angle by which the tangent of the ability of the lens to converge or diverge the rays, or we can also say measure of convergence or divergence. Right here, the measure of, one more definition, the measure of convergence or divergence. Convergence or the measure of convergence or divergence, okay, is known as power of lens or tangent of the angle by which. Next one is the tangent of the angle, by which it converges or diverges, by which it converges or diverges. Converges or diverges a beam of light at unit distance. A beam of light by unit distance. Beam of light by unit distance. Unit distance from the optic center. From the optical center. From the optical center. That is known as power of a lens. There are different definitions. 1, 2, 3, 4. 4 definitions we have. Okay. Next one. This will be useful for your Viva also. Now tan delta is equal to what? Tan delta equal to what? H by L. Because we wrote H is equal to 1. H value is equal to 1. Then what will happen? Tan delta will be equal to, tan delta is equal to 1 by L. Now, if it is small, if delta is small, what will happen? Tan delta will be equal to delta. Okay. So we can write delta equal to what? 1 by L. So here we are writing P is equal to 1 by L. Is that clear? P is equal to 1 by L. Understood? So reciprocal of focal length. And units of power is what? Units of power, it is diopters. D, capital D. You can write diopters or per meter. And also P is positive for which lens? P is positive for convex or concave?
Convex.
Convex lens. And P is negative for
Concave.
concave lens. Very good. Concave lens. Is that clear? So suppose if F is equal to 40 centimeter, minus 40 centimeter, how much will be the power? Minus 1 by 40 centimeter will be equal to how many meters? 0.4, right?
Yes.
Will be 0.4. That will become equal to how much? Minus 1 by 4 by 10. 4 by 10 by 4. Which will be equal to minus 5 by 2, right? Minus 5 by 2 or minus 2.5. P will be equal to minus 2.5 diopters. This is the way we do it. Clear? This is one example.
Yes, sir.
Okay. Now we will go to magnification, then we will go to combination of lenses. Okay. Magnification and combination of lenses.
So magnification, we already did it, right?
No, this is one is linear magnification, the other is angular magnification. That we have to do. Angular magnification also will explain. Now, quickly
Oh, okay.
we'll go to angular magnification, then we'll go to combination of lenses. Any doubt in this?
No, sir.
No. Okay. Going ahead. So shall I raise this? Or take a screenshot. Okay. So shall I raise this?
Yes, sir.
Okay. Yes, madam.
Yes, sir.
Okay. Now, angular magnification. So we have two types of magnification. We have linear magnification and angular magnification. In linear magnification, we write here small m. Small m is equal to h dash by h, which is equal to b by u. Image distance upon object distance, height of the image by height of the object. Second one is angular magnification. Angular, small m is the symbol for linear magnification. Angular magnification is denoted by capital M. Okay, so what is that? That is angle subtended by image. I'll first draw the diagram. See, this is the lens. Now, what happens? This is the object. Now, this is the image. OJ is the object. IG is the image. This is alpha and this is beta. Okay, so angle subtended by object, image to angle subtended by image to angle subtended by object. Angle subtended by the object. Okay, that is said to be what? Angular magnification. So we are writing capital M is equal to what? Tan beta divided by tan alpha. Okay, tan beta by tan alpha. Is that clear? So this is the formula, or beta by alpha we can write. Is that clear?
Yes, sir.
Next one is combination of lenses. The derivation is not there. Combination of lenses derivation is not there. Only the formulas are important. Now, next concept is combination of lenses. So, combination of lenses. In combination of lenses, we have, like suppose we can add two lenses like this. There are two lenses like this. Two convex lenses, a concave and convex lens, or two concave lenses. Like anything, it can be like a combination. Okay, like this. Understood? So there are different combinations: two convex lenses, two concave lenses, a convex and concave, and two concave lenses. Now, what is the formula here? He says that if focal length of this is f1 and this is f2, so we write generally 1 by f. Total combined focal length is f1 plus f2. If it is positive, take. If it is convex, take positive. If it is concave, take negative. Now, power will be how much? Like this, we carry on. Like if there are more than two lenses, we just add it. Or we can also write P is equal to P1 plus P2 plus P3. Keep on just adding the power of the lens. Third one is magnification. Okay. So, combined magnification. Magnification here it gives, it gives the sharpness of the image. Okay. Combination, it gives the sharpness of the image. So, magnification or sharpness of the image is given by formula m equal to what? M1 into M2 into M3 into that. Is that clear? M1, M2, M3, keep on going. So here the focal length 1 by f is equal to 1 by f1 plus 1 by f2 plus 1 by f3. P is equal to P1 plus P2 plus P3. Or magnification or sharpness is M equal to M1 into M3 into M3. Is that clear?
Yes, sir.
Okay. Now we'll go through refraction through a prism now. One of the important derivations. Refraction through a prism. So once we are done with refraction through a prism, we will start optical instruments then. The telescopes and microscopes. Okay. Just give me a minute. Now, the next concept is refraction through a prism. Refraction through a prism. So suppose this is a prism now. A, B, C is a prism. A, B and AC are refracting surfaces. A, B, C is a prism. Okay, A, B, C is a prism. A, B, comma, AC are refracting surfaces. Refracting surfaces. Now, BC is base of the prism. BC is base of the prism. Now, here N1 is N1 comma N2 or normals. N1 comma N2 or normals to AB and AC respectively. AB and AC respectively. Okay. Now, here PQ is the incident ray. Okay. PQ is incident ray. PQ is incident ray. Then QR is refracted ray. QR is refracted ray. And RS is what? RS is emergent ray. RS is emergent ray. Now PQ, QR, and RS. Now here I is the angle of incidence, R1 is the R1 R2 or the angle of refraction, and E is the angle of emergence. E is the angle of emergence. I'll write here. Now here, what we are writing, angle I. This is angle of incidence. Angle of incidence. R1 comma R2 or angle of refraction. And E is angle of emergence. Angle of emergence. Okay. Now, angle of emergence. Now, we have these two normals are meeting at end. So we have a quadrilateral. We have a quadrilateral. Quadrilateral, what is that? AQ and R. So the sum of the angles in AQ and R is 360 degrees, quadrilateral. So what will happen? These two are 90 degrees. This and this one is 90 degrees. Because normal and the surface 90 degrees, normal and the surface 90 degrees. So angle A plus angle Q and R is equal to how much? 180 degrees. Here, angle A plus angle Q and R is 180 degrees. Now if you take the triangle, Q and R, sum of the angles in a triangle is 180 degrees, right? Angle R1 plus angle R2 plus angle Q and R. Okay, angle Q and R is equal to again 180 degrees. Now we will solve this equation. How do we solve here? Angle A is equal to 180 degree minus angle Q and R. Similarly, here R1 plus R2 is equal to 180 degree minus angle Q and R. So that will happen, angle A equal to what? Angle R1 plus angle R. This is the first equation. Now, this is the first equation. Now, what is this? This now the angle of deviation, angle between the incident ray and the emergent ray is said to be angle of deviation. Angle between the incident ray, this is the incident, we are stretching the incident ray, and we are stretching the emergent ray. So they meet at this point. So where the angle is angle of deviation. So what is this angle of deviation? Exterior angle is equal to sum of two interior opposite angles. Exterior angle is equal to sum of two interior opposite angles. What is this angle? I minus R1. What is this angle? E minus R2. Understood? Is that clear? This is I minus R1 and this is E minus R2. So I will highlight here. I'll highlight with the red pen here. Like I want this value. this value and this value. Okay, these two values. So it says that is what. So we can write delta exterior angle is equal to sum of two interior opposite angles. Sum of two interior opposite angles. Interior opposite angles. So what it will be now? Delta will be equal to I minus R1 plus E minus R2. So delta is equal to what? I plus E minus R1 plus R2. But what is R1 plus R2? R1 plus R2 is A, angle A. So delta is equal to I plus E minus A. So in simple words, what we can write now? I plus E is equal to A plus delta. Understood? I plus E is equal to A plus delta. Is this clear?
Yes, sir.
Okay. So we can take the screenshot of this. I'll stop here. Tomorrow I will take the class.